Hey, we're going to work on our 3.1 notes, which is where we're going to determine if things are functions or not and what are functions and a lot of vocabulary. So let's start with the vocabulary. A relation. This pairs inputs with outputs. So it pairs inputs with outputs. You can pause this video at any point to get caught up on the vocabulary. I'm just going to go through it a little faster to get through the notes quicker. A function is a relation that pairs each input with exactly one output. That's the key there. Exactly one output for every input. Domain. These are all, oops, if I can spell all. All the possible inputs for a function. And notice that when we are looking at the vocabulary word domain, it ends with the letters IN, so domain is also your inputs. We're also going to learn that your domain is your x values as well. So when you have a function, your x values are going to be your inputs. Let's go over to range. So range are all the possible outputs of a function. And if domain are inputs, that means range are outputs, also your y values. Now let's get to independent and dependent variable. Independent variable. It's the variable that represents the input. Which means the dependent variable is the variable that represents the output. It depends on or relies on the independent variable. Boom. So there's your vocabulary. You're going to be hearing a lot of these, so at least we have to go over them so you understand them. All right, example 1. Determine whether each relation is a function and then explain. So our idea here is we want to look for, does each input have exactly one output? So what I like to do is I like to look for repeating inputs. If you don't have any that repeat, then it's guaranteed to be a function. If they do repeat, then you have to check on the outputs. Okay, so let's look at all of the inputs here. I have a -2, -1, a 0, 1, and a 2. So there are no repeating no repeating inputs. So this we would say is, yes, it is a function. Because each input has exactly one output. Again, these notes are pretty long, so feel free to pause this whenever you want to, so you can catch up. Second one, let's look at our inputs. 4, 8, 6, 4. Whoa! I see another 4 there. So I have 2 4s, and then I have a 5. So what I want to do is I want to look at their outputs. I have a 0 and then I have a 3. Notice how when I plug in the number 4, I get two different things out. It's sort of like a pop machine. If I keep pressing the Pepsi button, I should keep getting out Pepsi, but if I get a Coke out instead, or a Diet Pepsi, I'm not going to be very happy. So this would not be a function. So I'm going to write that in here. So I'm going to say not a function because the input of 4 has two different outputs. The input of 4 has two different outputs. We can do the same thing with a table. Look at our inputs, look at our outputs. So let's see, I have -2, -1, 0, 0. Whoa, I have 2 zeros. So right there I can stop and look at their outputs. One has a 5 and one has a 6, which means not a function because the input of 0 has two different outputs. And then this is what's called a mapping diagram. So our inputs, notice that each one has its own output going away out from it. So which means yes, it is a function. So I'm going to type that, I'm going to write that in here. Yes, it is a function because each input has exactly one output. I want to do one other side example here. Maybe this is like example E. If I had 0, 2, 1, 3, 0, 2, 3, 8. Notice I have two of the same inputs, but notice my outputs are the same. Because my outputs are the same there, in this example, I would say, yes, it is a function because each input has exactly one output. So just because it has repeating inputs doesn't mean it's not a function, but that's just when you need to look for it. If you want, you can do these on your own really quick. And then pause the video. I'm just going to write down what the answers are. So when you're doing these, the first one you end up getting a no. The second one you get a yes. The third one you get a yes. And the fourth one you get a no. I'm going to highlight why. You'll notice on this first one we have two inputs with two different outputs. And in the mapping diagram, notice we have one input that has three separate outputs. All right, core concept here. Vertical line test. This is a graph that represents a function with no vertical lines passing through. So basically, if your x's are your inputs, and you look at a graph right here, this would be an x value of, let's say, I don't know, of like 3. Notice I have two ordered pairs here. This would sort of be like 3, 4, and maybe this one's 3, 2, and notice they're the same inputs but different outputs. So you can make a vertical line anywhere in the graph, and if it touches more than one point at a time, it doesn't pass. We can abbreviate this as a vertical line test when we do this. So let's look at some examples here. Determine whether each graph represents a function, and right away I can see with graph A that these two spots right here do not pass the vertical line test. So my answer here would be no, because it does not pass the vertical line test. Or if I look at example B, anywhere I draw vertical lines, it touches the graph only in one spot. And because of that, I can say, yes, it is a function because it passes the vertical line test. So you can look at a table, a graph, a mapping diagram, and look at inputs and outputs. Or you can look at a graph and look at the vertical line test. So these on your own, if you want to, you can pause the video and try them. Then I'm going to write down what these answers are. Number 5 is a yes, 6 is a yes, 8 is a yes, number 7 is the no, because pretty much anywhere on this circle, you draw a vertical line, you're going to touch the graph in 2 spots. Pretty much anywhere. You just need to find one spot, only one spot that has it, and then it's a no. All right, domain and range. Domain is all the possible inputs, range is all the possible outputs, and this is a function machine. So as I plug in the -2, there's this rule called a function. It says that my output is equal to 3 times my input, and then it tells you what the output is. So that is a function machine. But domain and range, we want to find all of the possible inputs and outputs. So for domain, if you have individual points, you're going to have individual values. So I just want to find all the x values. So domain are your x values. Range is your y values. So this is skip counting. So my first x value goes right here, which is -3. And then I have -1, then 1 and 3. So those are all my domain values. Range would be my y values. So if I look at the y values, the first one is -2, then 0, +2, then +4. Now notice in example 3b, we have a continuous graph. It's connected, meaning it looks like our AND statement. Doesn't that look like an AND statement? That's an inequality. So my domain here has to be an inequality. So I want to find my smallest x value and my largest x value and throw in an AND statement. So my smallest x value is -2. So I have -2 less than equal to x less than equal to +3. Same thing for my range. I want to find my smallest y value less than or equal to y less than or equal to my largest y value. So my smallest y value is -1. My largest y value is 2, so I'm between -1 and +2 with this AND statement. But because I have closed circles on the graph, I have equal to symbols. So there's a couple on your own. You can stop the video, you can pause it and do those on your own, but I'm going to write down what these answers are. Domain for number 9 is -2, -1, 0, 1, and 2. And your range was 0, 2, and 4. Number 10, your domain is 1 less than or equal to x less than or equal to 5. And your range is 0 less than or equal to y less than or equal to 4. Okay, I'm going to do this last example. I'm not going to do that on your own, but I'm just going to do this last example. It says the function y equals -3x plus 12 represents the amount of y in fluid ounces of juice remaining in a bottle after you take x gulps. So what happens here is the juice remaining depends on the number of gulps taken. So they want to identify the independent and dependent variables. Since the juice depends on the number of gulps, that means gulps, which is your x value, is the independent variable. That means the juice remaining which are your y values, is the dependent variable. Last thing it asks is the domain is 0, 1, 2, 3, and 4. What is the range? So we make a little t-chart, double t-chart actually, like this. So domain, x values, y values, we're going to go 0, 1, 2, 3, and 4. And here is our function. Our function is negative 3x plus 12. So I'm going to do negative 3 times 0 plus 12. Negative 3 times 1 plus 12. Negative 3 times 2 plus 12. Negative 3 times 3 plus 12. And then negative 3 times 4 plus 12. And my outputs are going to give me 12, 9, 6, 3, and 0. So those are my outputs. That's my range. So my range from least to greatest, 0, 3, 6, 9, 12. Another way we can do this is on our graphing calculator. So here's your handy dandy graphing calculator. You can go to your y equals up here and type in your equation, which is negative 3x plus 12. Helps if I get the plus sign in there. Plus 12. And then we can go to a table of values that's already made for us. So second table. And notice I have this table of values, and I just need to look for the domain or the x values of 0, 1, 2, 3, and 4. So here's 0, here's 1, here's 2, here's 3, here's 4. So this section right here would be my output. So your calculator can do that for you as well. All right, you can do that on your own if you want. I'm not going to do those right now, but I hope that's helpful, and best of luck to you and this lesson.